I'm very honored to discuss with you guys such a emerging technology, deep learning, and it essential. And please let me know if you can see my screen.
Yeah, it's visible, Suman.
Okay. So basically, we will be discussing one of the framework which is used to develop deep learning models or machine learning models nowadays, and it is more inclined to the coming world of AI, which is Pytorch. It is developed by Facebook AI team, and it is an open source library, which is the best thing for a researcher or any user in commercial domain. So when we come to PyTorch, we get much more flexibility and speed and computational power, because earlier the libraries like NumPy, which is also used to handle matrix, or SciPy, were not added with the GPU support, but when the PyTorch or TensorFlow, because we required heavy GPUs for training and image models in future. So how PyTorch is helping us, and why PyTorch? So why I'll tell you that it is very extensive reworking thing. It consumes very means time is very consumed, and we always go out of the hardwares and drives, and sometimes it take edges to train model. So we should focus on a framework which require very less time, very efficient, work on global systems. And so you can see how PyTorch is different from other thing is that first of all, it supports imperative programming, same like Python. You can always test your code on fly. You can check your next line in the next time. If you go to some other languages like C++, other, you have to run the whole code to check your changes. But coming with machine learning time, everybody want to check the data set or sanity check for every line and each line, and then proceed further. So you can check that we have a thing here that also called dynamic computation graphic, which helps her in getting these differential equations at a fly also, which is a very important thing, which earlier speaker was talking about the backprop thing. And to get the weights, we have to do some differential equations and to propagate the loss. So for doing that, we have a dynamic computing graphic. At the time only when we declare a variable, it stores the differentiation of those things. So now coming to like how should we start with the PyTorch, and what thing we should have with ourselves if you want to just use this library either for research purposes or learning or even in a industrial field. So here is I provided a link here. I'll be sharing this notebook to you guys later also. So this is an official website of PyTorch, and if you go to this website, you will find all those OS which are supported. So it is widely accepted in Linux, Mac, and Windows system. Also, what kind of installation you are looking for. For a simple user, pip installation is always famous. So let me just guide you through it and do it with you. So you can find a stable version, other versions available here. Whatever is your OS, just choose your OS like Windows, and whatever the packages you are trying to install with, either condas or pip, whatever the languages you are trying to be with, either Python or C++, more on a development side. And for Python, you have to choose pip. So CUDA, this is a very important thing, because also Arunjan mentioned that NVIDIA's guys are coming. So it is developed by them, and it is the main hardware which converts our tensors and handle it. So you have to check your driver version, like whatever NVIDIA GPU processors you are having, and you have to choose a CUDA according to that. And let's say if you don't have any hardware, no need to worry. It also CPUs also support that. So use CPU for that, and simply move ahead. You will get the syntax below this command. Just run this command in your Python command prompt. I'll just show it how to do on local machine. So just run it here, and you will able to install it. For those guys who are also willing to not install on local system, or somehow doesn't support a very big hardware constraint is there. So you can look into, I'll just, you can look into something called Google Colab. Simply just do Google with these keywords. Whatever the first search comes, you can go there. Once you go there, just log in and click on create a new notebook. Once this notebook is created, you are free to use this notebook. As you can see, you can simply connect to the runtime. And once it is connected, you can see what support you are getting. Let's say you are getting 12 GB RAM in this current session, and something 107 GBs for the hardest thing. And you can simply name your notebook like Hello World. And
Sumant, I
yes,
think the screen is not getting shared. Okay.
okay, just a minute, just
Yeah. Yeah. Can you just check it once?
okay. Is it visible now?
Yeah. Now it's actually that I think one
Session of I
window.
think collab is missed or Pytorch.
Uh, collab.
Okay, okay. Can you see collab on my screen right now?
Yeah. Yeah. Now it's yes. Yes.
Okay, okay. I'll re-guide from.
Yeah.
Okay, so you can basically go on Google and sorry for interruption.
Yeah. No problem.
Yeah,
Thank you, Gurpreet Ravi Vishwas for pointing it out.
yes, yes. You can just write collab here, Google Collab. You can do parallelly with me. You can just write Google Collab here. Whatever the first search comes, click on that. You will landing to this page if you're already signed into Google account. If not, please sign in. Just click on start a new notebook. You will reach to this page. And so I'll just guide you. Here you have to give the notebook name. You can write Hello World or whatever is your notebook name. You can simply connect, click on connect, then it will connect to the host machine. Once it is connected, you can check your system configuration, which has been provided to you. In this case, it is 12 GB RAM and 107 GB hard disk we are getting right now with Python 3 version. You can just print anything just to start. We can print hello world, and on this go you can do these things. Also, I'll try to tell you that there is a drive folder. You can upload your data and get access from here. So this is one basic thing which you can have an idea about how to use Collab. And now next, moving to the session which we are focusing on introduction of PyTorch. So first of all, I'll tell you how to. It's one of the Collab notebook which you have seen earlier. Simply you can click on import torch. It's a way of initializing a torch version, and you can click on torch.version. So just to be confirm what version you are having. If you're having CUDA or installed with GPU, you will get this version like CUDA. If not, then you will get anything else. And then click on here to check the device if higher computational hardware is present. If CPU is present, then CPU will come up here. If GPU is present, then GPU device number will come. I'll show you how to convert this notebook a GPU support. Just simply click on runtime, change runtime, and click on GPU. You also have option of TPU if you are training a very heavy model in NLP or any computer vision domain field. Just click on GPU, click on save. It will start again relocating that thing, and it will restart your notebook. So once it is connected, you can see again the system configuration, and it is handwritten that GPU supported backend here. So again, if I'll import the torch version. And now you can see it's coming as CUDA, which was coming earlier as CPU. So now I have a CUDA support on this live running notebook. So let us start with the first tensor we are trying to build today. This is the documentation of a tensor. I'm expecting you have a little knowledge of how Python works, what is vector, and some related to what is tensor. So tensor is nothing, the multi-dimensional vector, or you can say volumetric array is a tensor thing, which generally images are converted into. So this is my first tensor, and we are initializing a tensor of say three. Let me just 3 rows and 5 columns here. I've given a numeric value from 1 to 15, keeping the data type to float 32. device, which is the device I have assigned it earlier in CUDA in my case, requesting for grad. I wanted to calculate the differential equation on the fly, so I'm just keeping it to true. I'll just click hit enter. Once your tensor is generated, you can simply print your tensor. So you can see that the tensor is here. We have allocated these values to this variable, my first tensor. The format is in tensor. The device used is CUDA. Requires grad is true. And these are the values. We have got 3 rows and 5 columns in this particular dimension matrix. So we can also see what informations are here and other objects. Now coming to, if you just want to see what is the data type of this tensor specifically, not seeing all these information, we can always check the data type, which is coming torch float 32, which I have already given in a data type thing. And which device has been used for this? We can see that device tensor is on CUDA 0 currently. We wanted to check the shape. Many time when you are training a network, the shape will not be there and you have to always guess the shape to construct or build a new network. So you can see the shape is 3:5, which was earlier decided, and check whether grad cam is true or false. We need to check if we want to do the differential on the time. So it is set to true. So this is how you initialize a tensor. Just to summary, put the variables, whatever you want, define the data type, device, and required grad. Sometimes these things are not required. They are set by default. You can just put your variables and proceed ahead. Now there can be different way of initialization because we always don't know the values of tensors or metrics even. So we can derive a empty tensor. Let's say if you are expecting some value of weight or bias, which is still to be defined or still to be filled in later phase when backpropagation happen or when your data set passes your network or architecture, then you have to define some variable which is has to be uninitialized data set, some random value. Just you have to maintain the aspect of that matrix to consume the data from the different layers of input and output. Then you can just define an input set, just give some tuple of size, whatever you want. If you want 3 by 3 or 4 by 4, you can just change it to anything. And whatever changes you make, it will make the osmos thing and it will have some random values, doesn't have any relation with itself. And let's say if you want to initialize some matrix which is having some zero values, so that if some addition happens, like this is a very popular in case of when we are defining biases in the network, we generally keep it zero or give some random initiations. So you wanted to make a zero matrix. So you can see this. This is coming 0, 3 by 3 matrix, shape 0. Also, sometimes you need to generate some random matrix. These are ways of initializing a matrix, which will help us in later defining what is a model and how to make a model. In those things, this initialization used to help us. Also, these are pretty much random values which will be generated here. If you set some random seeds in and around, then these values will be coming same. And these intervals are basically from 0 to 1. Now coming to the identity matrix, if you want to build an identity matrix from a single code, so this could be an idea because previously we are generating some random values, some zero values, but identity matrix has its own importance while doing some various calculation. So we can see that just putting a torch once 3 into 3 will get you a matrix of 1 1 1. And if you want to generate identity matrix, you can see it has its own importance. So you can use torch.I and you can use 5 by 5 matrix. Let's say if you want to generate a matrix using torch and you wanted to give some start and end range as popular this range function in Python. So you can always give a start value 0, end value in my case I've given 5 and a step 2. So you can print this single vector, and you can see the value is coming from 0 to 4. If you keep changing it to any values, it, it will, and put any step here, it will just jump out and take those arithmetic steps to come there, and those values will come here. So this is also very helpful in initializing a tensor. Now coming to making those tensor which is having some statistical constraint into it. So by statistical constraint, I mean you want to vary those mean and standard deviation up to some mark, so that to match the data. In machine learning algorithms, many times we always wanted a data set to be normally distributed to have a better convergence on the model, and also to make a computational less expensive, because when you bring your model from 0 to 1, it is very helpful. So following those distribution in statistics, you can use this command where you write torch.empty and you give the size, and you then put normal command giving mean and standard deviation. Like let's say I just want to do some normal distribution. We all know normal distribution means 0, and giving some standard deviation to it. So if we click on that, you can just get your tensor for that. So these all from different ways of initializing a tensor. Let me just summarize for it for you. One was just to declare some empty tensor where no values is been initiated by us. It's some random values. We are just getting those metrics. Another was building a torch with 0. So we are getting a 0, 0 torch matrix from here. Some random values, again putting it to random, but we are giving some definite number to it, and then all the matrix with value ones using torch ones script, giving torch I to get a identity matrix one, and arrange to use start and then step function to get a range of the range of the arrays with certain steps from end to start, and some empty thing, and again initializing it to normal values of mean and standard deviation. So these are 4 or 5 ways in which you can always initiate your tensor and proceed ahead with performing some task. So let's say now coming to how to make a initialization of a tensor to of other types, maybe float in or any other data type you want to switch from, because you might be data you have downloaded or acquired have some constraint, and the way you want to perform will have different constraint. So you need to switch your data from one format to another format. So in this case, as I explained earlier, I'm using arrange function and just initializing one data set of a 10 number of length. So you can see the data set is here. Right now, I wanted this particular tensor to be converted to Boolean. So tensor Pytorch provided a very good function called tensor.boolean. You simply click here by giving this tensor and then Boolean. You will get, if it is positive, then all values will come true. And if anything is 0, that will come as false. As simple as that. Even you give some negative values. Let me just, I'll just give values and show it to you. And if I can try to convert this into a Boolean tensor, then everything will comes true, because only 0 and binary digit number is considered as false and rest all true. So that's how you can convert your data set to any Boolean data set. It is very much helpful when we try to make some binary classification, which a previous speaker was talking about. Let's say you want to make a cat or dog classification, or any single class classifications in the machine learning algorithm, then you can focus on these kind of tensor. You will be looking for that whatever the prediction which is coming above beyond 0, it is true, and which is always is coming as a cat, which is false. So you can use this tensor in those cases. And then coming to changing the int 16 data set here. So you can see that we are able to convert the data type from 32 to 16. And again, we are able to convert it to float. Just putting that tensor name and using the sort function or float function, you can different function, you can just put it around behind that tensor and you can just define those values. And also you can allocate these tensor to new variables. This is just I'm printing the variable, so let me just. So you can see this, whatever is the latest float version of that data type is coming here, float 64. Earlier when we defined it, it was 32, I guess, 32 and 32. And later it is coming to float 64. In this way, you can convert your data types and switch from one data type to another. Just to give a summary again, we can convert to Boolean. We can convert it to float 32, 64, whatever is the data type available on Pytorch. You can convert from one data set to another data set. But it should be a meaningful conversion only, means there should be a space of converting int to float and float to int. You can't convert a Boolean to float something. You will get just 0 and 1 values. So you have to do it. Computer is not that creative, and you have to be creative while converting your data types. So let's perform some mathematical calculation in PyTorch, and how should we proceed with those calculations. So here we can see that there's two variable which has been defined already, two variables. We will play with these two variables, x and y. So x and y's are two variables. X and y's are two variables here, and I have given x as 1, 2, 3, and you can see y as 9, 8, 7. So I have defined some values to this variable. We can also define these values and we can initialize with different method which I have discussed earlier, like using zeros, ones, arrange, or I, or anything or in range in step and end function. So you can define these simple arrays. These are some arbitrary matrix, and we wanted to do some comparison. Like if we want to just check the comparison of x, like how many data sets are above 0. So let's just do that. So you can see that these are the comparison we can perform here, comparison operations. We are simply giving a value 0 to true, whatever is the, sorry, let me just rerun it. It is showing some extra values. So it is coming true for all the values which are greater than 0. If we put it to 2, then it will come false for these two values. As you can see, the x is having 1 and 2 first element, and second elements are not more than 2, and for the third element it is true, so it will come like that. Likewise, you can perform other thing also, like less than 95. Not only 0 is very specific, you can use any integer here and simply do the comparison and get to know about things. So you can see these, all these values are less or greater, it will come here. So in the next session, we are talking about the addition methods, like how to add these two values and how to subtract these two values. So this x and y, which I have defined earlier. So I am creating one empty matrix without initializing any value to it, and adding those torch values, this x and y here, x and y here, to give it an output in z1. So to perform this addition, we can simply run the torch script, like writing torch.add. So it will add those values. You can see the summation here, like 9 plus 1, 8 plus 2, it's all coming to 10. So in that similar fashion, we are getting these values 10, 10 here by just adding. The another way could be adding it, that not giving any initialization, like where you want to allocate this value, just directly want to allocate this value to some variable. So you can simply put this variable, right, torch.add and x and y here, and if you run it, you will get again these values. So here what we have done is that we have defined one variable and also defined the area of that variable, that what will be the shape of that variable. and simply in placing these values into here. And here what we are doing, that we are directly assigning those values by using the add function of torch. And of course, my favorite thing is that we can simply add it by using x plus y. But this is just to give you sense that when you develop a different network, if you need to add your weight into feature plus bias, then how should you proceed? Where should you put your output again and again? It give more sense to us, like how things are working. And you can always have a trail, because when we always develop a bigger architecture, we want to maintain some trail in the network and to see where is coming from and where it is going to make that flow. It is very much helpful. Now this is the addition thing, and three ways we can add it. Either we can allocate it directly to the variable or do the summations, or we can just define any variable and then try to allocate it. Now coming through the next thing in mathematics only, a calculation, which is matrix multiplication. Again, a very popular thing to do in all the machine learning and AI structure, because we are simply multiplying weight into the features and getting those values and comparing it. And also to perform lots of convolutions in the deep learning domain related to computer vision, this matrix multiplication plays a huge role to us. And so in this, again, I'm defining two variables here, x1 and x2, giving some random initialization, starting from 2 ending to 5, starting from 5 ending to 3, and doing mm is assigned for a matrix multiplication. It's a short form of matrix multiplication we simply run it and we get our. Also, you can look into what was the actual multiplication is. So you can look into x1. So these were the two metrics which we have multiplied. We know the matrix rule to be holds true, having same number of rows and columns. So we get about these matrix. And if you check these matrix, we have got 2 into 3 matrix. If you multiply 2 by 5 matrix into 5 by 3 matrix. Also, we can also do it in a other way, rather than writing it into torch.mm.x1 into x2. We can write in some efficient manner. That could be writing the first variable here dot mm and writing the second variable here and assigning it to a new variable. So in this way also you can get the matrix value. You can see these two values are same. So when we come to the deep learning domain, we just with a single multiplication we can't proceed, because you will have a batches of images with you. You will have batches of data set with you which you want to multiply it and get the value. You will be training with multiple or very big number of data set. To handle that, we should able to multiply the matrix in batches, and we should know how to do these things in batches, so that we have an idea. Okay, if I get 32 of a batch, and if you make a split of test, let's say test 28 and train train 4. So how to do this multiplication for this 28 in a go, and for this train 4 in a go? Sorry, it's just logically we should give more data set for training and less for testing the split. So to do that, I'll be telling how to do this batch matrix multiplication here. For doing the batch multiplication, you just define it can be a different way to do. It's just a personal choice. It's not something very standard how you should do it. I'm showing my way of doing it. So I generally put a batch of 32. Let's say 32 images are there, or let's say 32 objects are there, or 32 training samples are there. We are just defining the number of n, like what is the rows or columns we are saying. Again, defining m and p. So that's how I get two matrix. Let's say this matrix being a weight matrix, and let's say this matrix being a bias matrix. You can always set this parameter depending upon your need and uses. So let's say if this is a weight matrix, and this is a bias matrix. This is a training sample. X feature matrix. And if you want to multiply these two uh, to get a linear equation, a simple linear equation, You can simply multiply it. This is currently I'm printing the shape to get these. Let me just. This will be your matrix. Like if you, let's say if you have a matrix of 10 into 20 into 30, so this will be your matrix. And later you can also add your biases using this add multiplication, which I have shown you here. You can simply later on in this can add your biases and get that value of y. That will be your y prediction. So this batch multiplication and additions are very much helpful when you are, because all the deep learning and AI things basically work on multiplying the weights with the current nodes. So in that case, we just need to use this multiplication and addition to get these values. So later coming to how to index and reshape some certain kind of matrix and arrays. So let's say the same matrix which I have used earlier, to keeping that in mind. I'm just defining one variable x here. Let keep it simple for a while. So I've just defined a matrix with 1 is to 8. So only one row and 8 columns. And let's say I want to navigate to this first value of this example. So how should we do that? So that's how if I'm just trying to get the shape of this first row, particularly this first row. So if we write x dot shape, we will getting that first row value. If you just want to get the shape of this matrix, let's say you don't know. So it is 1 is to 8. Let me just for better understanding, I'm making it of a more dimension so that I can tell you about the usability of this indexing and reshaping of the matrices or tensor in this case. So if you just print what is x0, x0 is basically this row and how many elements are in that. So get the first examples feature. Let's say if this is a training example, let's say this is a training example. This is number of training example. Let's say if this is number of training example and this is the features. So let's say you have 3 training examples of somewhere, and let's say this is a 5 feature. So just for the sake of explanation, let's say this is a climate data, and you have recorded our data for three locations, 3 different locations, and this can be a temperature, this can be a wind velocity, this can be soil surface temperature, this could be humidity, this could be aerosol content of the atmosphere. So these are the different features are available there. And let's say if you want to navigate to location 2 and check what is the that day temperature value and how you want to do that. You want to navigate to someday third location and you want to check the value for the humidity that particular day. Let's say this column is humidity. So how we can do this through indexing and reshaping helps that time to us. So that's how, like first row, this is already we are selecting the first row and this is we are putting the shape. So we are getting the shape. So we are getting, okay, there are 5 feature in the first row. And this is that how many those location exist. So we can check with this. These are the different shape values you can get it for different locations. And let me show you one slicing also. So this is the simple slicing. Yeah, these values indicate the rows values. Just and these values represent the columns values. So you just put the rows and columns in particular, and you will be reaching out to the different location on this matrix. And different wise, if you have a better if you want to do it in a together way, let's say if you want to access multiple data at the same time. So here I'm defining rows first and row second, sorry, first, second row and first row here. And here I'm defining a column to be fourth and zero. So we can get this data cumulatively also. No need to do it again and again. We can do it in a single go. Other way could be doing it is, so rather than doing it for multiple iteration, we can do it for single iteration also. So this was our matrix. Let me capture it. So this was the our earlier matrix which we have defined it there. So and if you want to go for the yeah, don't yeah, fifth column and the first column. So you can see the values and you can relocate. Okay, where is the first row and which is the second value of that, and which is the first row and second column of that. So by putting those values in together, you can get those values and read it out. Okay. So this is with the indexing and reshaping, that how to reshape your data and how to change an index through the whole matrix. Now coming to the one of the thing which I have mentioned earlier, that many of the data set is in NumPy values, and images are always easy to handle with NumPy. Is helpful in visualization, helpful in graph projections. So you can always convert your data from NumPy to Torch and Torch to NumPy. So for that conversion, there are a few available syntax for that. Just import NumPy as NP. Define any NumPy array, same zeros, which was valid for Torch also, and define a tensor and from NumPy. So this function from NumPy will convert this NumPy array into a Torch version. Or let me show you the data type. So you can see that this is simply a NumPy array having float 64. Once we run this, we can convert this NumPy array into Torch float 64, and it was initialized with 550. Also, sometimes it happens that we get our tensor and we wanted to convert this tensor to a particular value of a NumPy to do our visualization things, or we want to do some other changes or put in a SciPy library, or just want to store these NumPy values for future extraction and doing the calculations. So you can convert those arrays into a NumPy again by like doing this vice versa, like converting it from NumPy to Torch version and Torch version to NumPy version. So these all are the basics and basic understanding of how PyTorch works, how it handles with tensor, what is tensor basically, how you can initialize tensor. Next, I'll be talking about how to build some basic NN network. So I hope, okay, let me just. So this was related to the PyTorch thing. Just start, you can explore much more thing. It has much more capabilities. I have talked with very much basic needs and try to explain the usability of that thing. So now coming how to build NN network. So you all know, you might be aware. If not, so there are 5 cycle of building a network. One is most important part is preparing a data, then defining the desired model, then training that model, evaluating that model, and making predictions. So any model have this 5 life cycle in total. Prepared data can be manual or it can be accessible on other platforms. You can acquire it. A model can be by yourself or any existing model, or you want to build model. So I'll just show you how to build some small basic NN model just for the demo. Later you can build a model after this session, maybe depending upon your use also, and you can adapt with different available models throughout the globe. So how to build a model? These are some documentation which I have mentioned, which you can access later when I'll share this notebook. So to build a model, there are some, we have to make some necessary imports first of all. So what all needed to be imported, depending upon your uses and your checks, you have to import it. Still, I'll try to go through one by one. So you just initializing a torch version library here, like you do for any Python other library here. You're trying to import torch version because PyTorch was in torch, and you're trying to import NL functionality. So this is having some activation functions. You are I'm importing here a data set. So PyTorch is already having some sample amount of data set with them. So I'll be using those data set only today for explaining you. But you can also use your custom data set when you're trying to adapt it. There is something called transformation, which we do on data to augment it, sometime to increase more training samples. Here we are trying to import an optimizer like stochastic gradient or Adam or any optimizer. Here we are trying to import NN, which is able to build neural network modules. And here the most important thing in a PyTorch is a data loader. So it is other things you can find in other APIs and other spots also, but data loader it's very specific with PyTorch, and it gives an easier data management by creating a mini batches. So let's say if you're having very heavy data set, let's say around 1 million of samples, you can't train 1 billion on samples because of the hardware issue, or you can't manage the shuffling or putting any transformation into it. So here data loader comes handy to us, and these threes are simply helper function here, maybe avoided, maybe used depending upon a person's device. TQDM is just for getting that current update. Make grid is a function which is used to make grids, and this is from matplotlib just to make some projections. So here we are talking about, let's say if you want to build any a simple ANN model. So this is a sample ANN model. I'm not building the exact one, but somehow this one. So basically you get a input layer here. You get a hidden layer here, which is connected through, and then hidden layer, and then your output here. You can have a n number of node depending upon the your feature, and you can have n number of hidden layers depending upon your usability, and depending upon your number of classes, you can have an output layer. This is some basic knowledge for building a network. So let's start with building a network today. Let's say I'll be first explaining you how to build a model, a very small model for a day. So let's say I define a class with NNN. You can name it whatever you want. I've just named it NNN for myself. So I've been trying to build a neural network model here, and importing the NN module, which I talk about, which is used to build the network, defining the init function, first of all. What should be the input size? So what will be the input size of your data? Let's say in our case, the input size is 784 and the number of classes are 10. So my image size is 28 into 28, and number of classes are 10. For this use here, however, we are leaving it as a variable. I've just written for your understanding. So depending upon your image size, the input size will be decided. Now, depending upon your objectives and number of outcomes, your number of classes will be decided. So here you're defining that. This is the first layer I'm defining in this network. This first hidden layer can be assumed like this hidden layer. This is our image layer, which is coming into hidden layer. So we are giving that input size, the size of the images, and giving it a 50 nodes. 50 node means this node will be around 15 size, and all densely connected with each other. So this is just a dense network. So 50 node to that. This feature layer will be passed to another feature layer, which is having 50 nodes, because this was the output here. So this should be input to somewhere. We are plugging this thing here, and then we are converting that 50 node into 20 nodes. This can be a second hidden layer. This hidden layer we are decreasing those feature to capture the more features from the same data set. And then again, depending upon the number of the class, which is our last layer, output layer, we are giving it as a number of class and inputting the output feature as an input in the next layer. Whatever is the output from hidden layer goes to hidden two layer goes to output layer. Similar fashion, we are writing 50 to 50 here, then 20 to 20 here. If further layers was here, then I'd be writing this as a beginning layer input feature of this particular layer. So this is just with building the small network, but how we can how we can because if you know about architecture, we just pass this data set and we call it a forward pass. When we give our input feature and pass into these many layers, and there is something called back propagation which will be done in during the training process. So here in this particular thing, these are the just normal linear networks. We are trying to define put it in a ReLU to bring the non-linearity in. So here I'm calling the first FC1 feature layer, in which we am putting X, which is our input images, and assigning it to X again. And again, I'm putting this input, uh, this as an input in the next layer. So I'm putting this image into this layer as an input, and this input for a next hidden layer. So you can see that X is written here for FC1. Again, this X only is coming as a variable to this, and again assigned to a new variable X. And this is also coming to X. And this ReLU function is implemented on this layer so that we can get a particular get a particular linearity. This can be sigmoid or leaky ReLU, whatever is your choice of using an activation function. This is just an activation function. You can use any activation function here and put it here to pass your variable. Once your model is ready, in this case, let me just, oh, sorry, so all imports should be called before building a model. Okay, so once your model is ready with the input output and your desired objective, you can simply check your just as a ritual whether I'm GPU or CPU. These are the hyper parameters of the neural of our neural network, which depend upon the data set, and also experimenting to see like what can work better. So basically, I call it a knob, like knob you have in a radio or microwave to adjust some frequencies. So few things are static and few things are like your knobs. You have to adjust this knob to get a better to get a better model, or we call it sometime tuning a model with this learning rate, batch size, and number of epoch. So in our case, as I told you that our image is 28 by 28, and I'm giving it as a flatten layer, flatten in the sense like one for each pixel 111. So that will come around 784 pixel. Number of classes 10 in my case, and learning rate at at what every step the model should start learn. So that step I'm keeping it to 0.001. You can do some learning rate finder for just for basic model. I'm choosing it in a very hard way. Batch size I'm setting it to 64. It means that in 64 images will be picked first, and the losses will be calculated for then for next 64, and it will go till all the training samples it has been done. A number of epochs, that how many times I wanted this whole model to be data to be traced through this model, and where it should be updated. So that's how these are the hyperparameters which you have defined. I'll click here. And I'm just loading the data set. This data set I'm loading from Pytorch version only. So this is basically defining the route where to save this data set. This is a train data set. I'm assigned a train variable. So I've set train is equal to true. If it is test data set, you set train is equal to false. Transformation to tensor, because this data set was in NumPy. So I'm trying to transform it. Download is set to true. Meanwhile, I'll run also. So it will just download the data set in your PC, and you can see that it's downloaded in a root of data set here, which I explained that Collab provided this provision of saving this data set. So you can see it's had its own way of saving the data set in compressed format. So it is available here. You can also upload your local data set and then access it, not an issue here. And then here we come with a data loader. So as I talked about, that data loader work as a data management here. So in data loader, we are passing the train data set. We are passing the batch size, whatever the batch size we have kept here, whether we want to shuffle or not. And let's say if you want to perform any transformation, you can put any transformation value here, looking into the official Pytorch website, and that transformation will be performed on the fly. It will be not performed and stored in your system. That also help very computationally to us. So once this data set has been generated here, trace, test and train data set, we load into data loader, and train and data loader is in here. So just to visualize that what this trained data set look like to us, I'm using the famous MNIST data set in which we have 0 to 9 values and images related to it. So if you just click, you can see that this is the data set, and even I am printing the shape which I have defined earlier. Just for the shape, I have choose a batch size of 64. So you can see we are getting a 64 batch size and one image into 28 by 28. So one represent the channel of the image. This is basically a grayscale images. So these are having only one channel. So it is having one channel, and 28 and 28 is the pixel size, row and column of the one images. And that we are keeping as a 64. Those images are keeping that at. So this is the number of training samples. This is the number of channel of the image. This is the image size row, and this is the image column. Now let's initialize the model. So for initializing the model, as you remember, we have declared a variable of input size and number of classes. So we need to pass that how many classes and input size we are expecting. So we are just randomly initializing the variable, and here is the input size. As you can see, this is the knob which I was talking about, which pass everywhere. Number of classes set to 10 and input size is 784. Same variable which was assigned earlier will pass here, and it will generate a model. Here we comes with some more detailing of a function. Here we just decided what will be your model, but still there are other factors to be decided, like optimizer, what kind of optimizer you are going to use, what will be your loss function. So various loss functions are available on Torch, official Torch website. You can use whatever. Let's say this is a multi-class classification. We are using cross entropy loss. Here we are passing the learning rate. Here you can use Adam stochastic, whatever gradient you want, optimizer you want to use for convergence of the weights. In that way, you assign a loss and an optimizer here. This is a simple script written just for training a network. So already the number of epoch is set to 3. And when you run it, it starts train the model. So all it does is putting the data on the devices. Target on the devices means the CPU thing. The data is getting reshaped to a correct shape. This is the model which we have defined earlier, and these data set are passing into these models. This data set is passing into this model, and its scores are coming to get the loss here, which we have defined earlier. Particular loss has been generated from the scores and target, and this loss is then getting backward propagated, and optimizer is getting those differential value, and then it is getting back propagated. So that's how you can see how easy training with PyTorch. Just writing few numbers of code, we are able to do some heavy task here. And later we can just check the accuracy also of these models. Okay, what will be the accuracies? For defining the accuracies, all we do is we use one extra line is prediction one. We put the data set for the same model, we do some evaluation and pass those images into prediction thing and get the model. And then you can see the accuracies which is coming here for us in a while. So accuracy for training data set is 95 and test data set is 95.41. It's quite good, but of course the model is trained on very less data set and with different objective. It's just a basic model. So this is a simple NN model, which is not having just having some densely connected network and a nodes network. So now let's come to something which we are looking in deep learning is a convolution neural network. So how we can build some good CNN networks and how we can proceed. So here also I'm trying to explain you with a very simple network here, and we'll go through it quickly. So again, we defined any class with your objective name. I have given it a CNN. and giving the linear layer here. Then we are defining a first convolution. I hope you are aware with the convolution. It's a 2D convolution. Here is the number of input channel we are expecting, which will be the same as image channel. In this case, it is one because it's a grayscale images. How many output channel we are predicting? Let's say it can be a kernel. How much kernel you are giving it to it? How many filters you want out of those images? So in this case, this is 8. This is kernel size, how many pixel to be convoluted at a time with a certain matrix. This is the stride, what kernel should take, how many stride to cover the images. And this is padding, like how much padding you should provide across the images depending upon your kernel size. So whatever data you see here right now, stride 1 and padding 1, it will help you generally able to retain the same images. If you change the stride equal to 2, your image size will change again to half. If you provide padding is equal to more, so it does generally control the image shape. And just to maintain the simplicity, I'm giving it 111 so that we retain the same images. So that's how you initialize any convolution layer you want. There are other function also, like adding dropouts or adding bash norms, or how to initialize kernel. You can just write here and you can get it on the documentation and put it around in this thing and proceed. So next thing is about max pooling, one of the key aspects of deep learning again. So we are giving max pooling of kernel size 2 cross 2 and stride 2 cross 2 again here. And again, I'm defining a convolution neural network. As you know, convolution doesn't decrease the image size if stride and padding was one, which I explained earlier. After using the pooling, the size of the image will decrease. So number of input channels will change and we have to handle that. So I'm again defining one convolution. So that's how you simply in a super function, whatever the required max pool or whatever is the required your number of the layers, you define it here. And here how you develop your network, as we have done earlier, like forward pass. So here we are just creating those layers which will be used continuously in our layers, and then we are putting in a series of a way of calling those networks. So if you can see here that you can see that here that ReLU function we have defined. We have taken this convolution one, this first layer of deep network, and assigning it to the ReLU for giving it as activation function here, and passing this X, again passing this X into pooling layer, this pooling layer, and again passing this layer into convolution layer, and again performing some pooling layer, and then passing it to the final layer, which is this linear flatten layer, because the last layer in our case has to be flattened to make some 10 class prediction. Just because we are using max pool twice, the image size is getting decreased twice from 28 to 40. Here the image size will be 28, and from 28 to 14, and then to 7, and then we are making prediction from that. So that's how you build a simple CNN network. On the same data set on MNIST, I'll show you how to do. These are the knobs which I was just talking to you about. Just set the value of number of channel and classes. Initialize your CNN network. In earlier case, I have put model as a NN network. Now I'm initializing a CNN network. So here is I initialize the network. Whatever this is a summary. You can get a model summary, what you are trying to. Just, I think, okay, I just let just to show you the summary of the network. It is very handful that, okay, what kind of network you have built it out. Uh, okay, so this shows the summary of your network. So this particular forward network, what will be the output of this particular layer? You can see it here. Okay, the output shape will be this. How many parameters are being utilized? As you know, in max pool there is no parameters, so it's coming out 0. So after the first max pool, if you can see, the output shape is now 14 by 14. It has been decreased. Then we perform convolution layer, then again max pool, and then flattening those layers. So that's how you can check the summary of that CNN network, which was built using this class. Or you can, whatever the changes you make, you can easily check out here and do the necessary changes. And also it talk about how much total parameters are there and what is the trainable parameter, which is very useful in comparing with other models later on. And then you do some, again you initialize the loss function and optimizer depending upon your usability. After defining that, you train your network here. It will take some a minute. Okay, so I have already trained a network with here what I have done different from the above is that I wanted to also display what will be the current loss or accuracy during that time, that how model is learning with time, also showing that how batches are being completed. So this could be another way of uh, seeing the model. Just a minute. Okay, okay. Actually, I'm passing a wrong model. Okay, I think when something went with the model. So here you can see that which I was talking about to you is how to get the number of, you can also check the accuracies and the loss function in a Go. Was not able to present somehow. I don't know. So you can check those values like on the fly, you can check what is the accuracy, you can check what is the value of other specs and that. So you are able to train the model or the CNN model. And this is the way we are predicting an accuracy for the trained CNN model. So you can see that accuracy is coming around 98 and 98 for test. Earlier, as you can see, the accuracy was less as we have trained this model as a NN network, simply node network. But these are images, and we can get a better accuracies and inferences if we use a CNN model. If we use a CNN model, if we use a CNN model, we can get a better accuracy because CNN is more powerful in its own way, and you will get to know, I think, through this workshop. So that's how you train a CNN model. Apart from that, also I'll also tell you about other aspect quickly. There, Pytorch also provided you a different already pre-trained models. So these are the very popular models which are built in and around and have been proven very good with image classification, like you will be knowing like ResNetNet or DenseNet, Inception, all these models. So we can also utilize this existed model and adapt it and fine tune it rather than writing the model again and again, which is not the case all the time. People, we just use the architecture of a different existence and proceed with our objectives. So if you just want to use other people model or any model which has been renowned model, so you can simply go through this and click on any of the model or desired model what you want to be tested for yourself. Oh, sorry. So this is the way of calling the model, whatever model you want to call. Let's say I want to call VGG 16, which is model VGG 16 of 16 network. So we'll be calling this network just from Torch Vision import models, and for here you write, just capture this syntax and write here model.vg16. And let's say I want to pass an image of let's say I want to pass image of 3 into 32 by 32. Let me just, okay. And you if you print this model, you can see that all those convolution layer, ReLU network, max pool, all those operations are already been done here. Some adaptive average pooling, and you simply after getting this VGG model, you simply initialize this model. You simply initialize this model, putting a VGG here, and you follow the same steps, and you will able to train this model. Whatever we are able to initialize here, you are reaching again if you call this a pre-trained model. So that's how you get a pre-trained model. And also you can use other also. I've just shown you an RGB data set. So there's also an RGB data set and other data set, which I just leave it for you guys to try it on. I'll just share you how to. Yes. So this is the Cepher data set, very famous data set. It is also having 10 classes. The classes has been mentioned here, just to visualize that what images look like. So this is the image, and you can simply just, you can check, this is the data loader for this, and you can pass this value. Just a minute. Okay, I think I'm just missing out something, but you can just pass it. I'll show it on my developed network. You can just simply pass it here, and you can go get this RGB data set. So that's how with the training the model, which I was talking earlier. I'll just summarize it again. You guys, this is what I was talking about, preparing the data set the way we have downloaded the data set from different sources in any format, NumPy or Torch script. Then how we define a model, the way we define for NNN and the way we define for CNN. This is called defining of the model. Training the model, simply training with the normal epochs of the model. This is the training feature of the model. This is the accuracy and prediction of the model. That's how you will be checking that. Apart from that, there is also one thing I would like to, guys, that is. So this is one. This is the official website of Pytorch. It is very helpful. All these things which I have mentioned, you can clearly go and see here and try it out. They have much more better model and a very good explanation to each and detailing to each and everything, like how to build a neural network, how to do a forward pass, how to do those things. And also you can save this model. It's just you can save any model, you can load any model, you can load a model with weights, you can load just a model without mentioning the weights. So you can save our model and pass it to somebody else for transfer learning, and you can also pass it for other people to use your model if it is not being published just through local systems. And also there are other models available here which you will be going through, I think, in within a time, that how to use. You can just explore this site and you can check what are the other examples available here and how to use data loaders and data set. And you can also learn some basics from here, the same thing which I was trying to explain you guys. uh, this is one more famous data set of fashion show, in which people try to identify these 10 classes depending upon, and get used to it. So that's all from my side for today. If you have any query and questions, please let me know.
Thank you so much, Sumit. And it was very nice presentation, and I would say it was very practically oriented. And I hope participants will be able to correlate very well. Thank you so much, and you did extremely well, despite the fact that I contacted you in a very short